Let's solve another question on the production function. The question is, suppose the production function is q is equal to lk minus 0.2 l square minus 0.8 k square. L and k are the units of labor, and capital Q denotes the total output, and we are being told that let k is equal to 10. That means our capital is fixed. We have to find out the values of labor, where average product of labor and marginal product of labor are equal to 0, and at what values of labor average product of labor reaches its maximum. Okay, so we have this production function q is equal to this very thing. Okay, now we are being told k is equal to 10. That means capital is fixed. That means we plug k is equal to 10 in the given production function, so it will become, in place of k we have 10, so we have 10l minus 0.2 l square minus 0.8 k square means 10 square. 10 square is 100, so our production function will become this 10l minus 0.2 l square minus 80. Now what is average product of labor? It is simply the total product divided by labor. So dividing this production function with L, so we will get APL equal to, so this L is divided to each of these terms, so we will get, in the first term is 10, because 10, L gets cancelled, minus 0.2, here 1 L will get cancelled with L square, and in the last term we will have 80 upon L. This is our average product of labor. After that we need to find out the marginal product of labor. Marginal product of labor is simply the change in the total output due to the change in labor. Okay, this is our production function. The change in the production function due to the change in the labor gives us marginal product of labor. That means we differentiate this production function with respect to L. Derivative of L is 1, so we are left with 10, and derivative of L square is 2L, so 2 into 0.2 becomes 0.4L, and derivative of a constant is always 0. Now the question is, first part tells us find the value of L where APL is equal to 0. So when APL is equal to 0, so we equate this function with 0. So 10 minus 0.2 L minus 80 upon L is equal to 0, which implies, and let's rewrite it in this fashion. What can do we here? So we can write 0.2 L plus 80 upon L is equal to 10. Okay, so here it becomes 2 upon 10 L plus 80 upon L is equal to 10, or let us cross, or here we can write now 1 upon 5. 2 upon 10 will simplify to 1 upon 5, so we will get 1 upon 5 means L upon 5. Okay, so solving this here, so it becomes L square plus 8 5s are 40, 400 divided by 5 into L is 5L. Okay, is equal to 10. Again solving this, so we have L square plus 400, okay, is equal to 10 into 5 is 50L. Solving again, so we will get L square minus 50L plus 400 is equal to 0. Now this is a quadratic equation. We can solve it by using the quadratic formula. That is, L is equal to, let us say this, the coefficient of L square is A, the coefficient of L square denotes B, and the constant term is C. We use the quadratic formula, that is minus B plus minus B square minus 4AC upon twice A. Okay, now let's use the values here, which implies L is equal to, minus B means minus 50, so minus into minus is plus, so we'll get minus 50 plus minus B square means 50 square. Okay, minus 50 square, then we have minus 4 behalas 4 into A into C, so 4A is the coefficient of L square is 1, and we have here 400. Okay, to this we divide by twice A, so 2 into 1 is 2. Now for solving this, I have to rub this out. I don't have the space here. So we will get L is equal to minus into minus is plus 50, plus minus we get 50 square is 2500, because and the square of a negative term is positive, then we have minus 4 fours are 1600. Okay, 1600 upon 2, that gives us L will be equal to 50, plus minus 2500 minus 1600 is 900. Okay, 900 upon 2, which gives us L will be equal to 50, plus minus okun pan roz thoda roz okun pan 50 plus 30 upon 2. So L is equal to, either it is 50 plus 30 divided by 2, which gives us 80 upon 2, which is 40, 80 upon 2, which comes out to be 40, or L is equal to 50 minus 20 upon 2, that gives us 95 to go through, am I doing 95 through upon 2 is 15, either it is 15. I hope I am doing it correctly here, and let me see 5 shares of the sheet. Okay, 80 upon 2 is 40, so I got two values. So average product of labor is equal to 0 when either L is equal to 15, or it will become like this, it will intersect with graph here also, when L is equal to 40. Okay, this is the first part. Oh, and I'm really sorry if I have done miscalculation here. Okay, so average product of labor is equal to 0 when L is equal to 15 or L is equal to 40. A 2 point is average product of labor is equal to 0. Now second part is the marginal product of labor. Okay, so I'm really sorry I have Ahmed Karsab. Q is equal to 10L 1 such 10L minus 0.2 strawberry. Yes. So 0.2 L square minus 0.8 K square is 100. So it is 80 here. Okay. I am rewriting the production function with K is equal to 10. So it is here 80. Now what is marginal product of labor? Marginal product of labor is simply the derivative of the production function with respect to labor will give us the marginal product of labor. Derivative of 10 is, derivative of L is 1, so we are left with 10. Derivative of L square is 2L, so 2 into 0.2 is again 0.4, and derivative of the constant is 0. We are supposed to find out the value where MPL is equal to 0. So we set MPL is equal to 0. MPL is this 10 minus 0.4, L is equal to 0, or 0.4 L is equal to 10, or 4 upon 10 L is equal to 10, which means 4L is equal to 100, or L is equal to 100 upon 4, 100 upon 4. That means when marginal product of labor is 0 when we have L is equal to 25. Okay, when L is equal to 25, MPL is equal to 0. Okay, so this was the first part. Now the second part tells us at what values of LAPL reaches its maximum. Okay, so at what point is we need to find out. Again, let me rub this out. So this is Q is equal to this APL is simply Q upon L. Okay, so as I have explained, so APL is equal to 10 minus 0.2 L square minus 80. We divide it with L, so APL is equal to no, we have to find out the value of L where APL reaches maximum. Okay, so APL will be equal to 10 minus 0.2 minus 80 upon L. Okay, now APL is maximum when slope of APL is 0. Okay, so at a point APL will be maximum when the slope of APL is equal to 0. Now what is slope of APL? Slope of APL means the derivative of average product of labor function with respect to labor, and we set it equal to 0. Now derivative of this function, derivative of a constant is 0. Derivative here we have L. I am really sorry for these mistakes. So derivative of L is here 1, so we are left with minus 0.2 minus derivative of 80 upon, sorry, 1 upon L square, it will become plus 80 upon L square. Okay, derivative of 1 upon L is minus 1 upon L square. Okay, and we set it equal to 0, which implies 80 upon L square is equal to 0.2, or 80 upon L square is equal to 2 upon 10. We can write 2 upon 10 is 1 upon 5, which implies L square is equal to 5 8s are 40. So 400 L square is equal to 400 implies L is equal to, transposing it will become plus minus 400. Okay, when we transpose square it will become root here, and we will get two values here. That means L will be equal to square root of 400 is 20. So we got two values. L will be average product of labor will be maximum. Okay, since we are only involved and we are interested in only positive values of labor, so we set only, we take only positive root here. Okay, so we will get L is equal to 20. Okay, when L is equal to 20, average product of labor is maximum. I hope I make myself clear in this video. Thank you.